Hello Year 9 Sciences, Mr. Da Silva here with the first video of the series Plate Tectonics. In this video we'll be investigating the topic of Earth's structure. Let's go for it. And we start the session with our essential question. How can I create a two-scale representation of Earth, chemical and mechanical layers? So I encourage you to stop the video now and copy that on your workbook. And here is our very first concept for this topic. The Earth is composed of many different layers, which are classified using the chemistry of rocks and how such rocks behave mechanically. Today we have a pretty good idea of what lies within our planet's interior. Our current understanding indicates that our planet has two distinct layers called chemical and mechanical layers. And here's a breakdown of what the chemical layer looks like. This layer contains the oceanic crust, the continental crust, the mantle, and the core. So if we were to break that down into a more visual diagram, this is what you'll be able to see. The continental crust and the oceanic crust, they have a depth of around 100 kilometers. So it starts at the surface, obviously, it goes all the way down to 100 kilometers. The mantle, it starts at 100 kilometers, it goes all the way down to 2,900 kilometers in depth. Now the core starts at 2,900 and goes all the way to the center of the planet. I highly encourage you to stop the video and copy that information onto your workbook. Now it is the time for us to discuss the mechanical layer. It is structured in the following way. You start with the lithosphere, then you have the asthenosphere, mesosphere, inner core and outer core, and this is pretty much what it looks like if you have a look on the right side of the image there. Here, so you have your lithosphere, which comprises the continental and oceanic crust. Then you have your asthenosphere, your mesosphere, outer core and inner core. And on the left side here, this table, it's showing you pretty much all the information that you need to know about those layers. I would also encourage you to stop the video and copy that table onto your workbook. You might be asking right now, what are the differences visually between the continental crust and the oceanic crust? Today's your lucky day. I've got some samples for you. So let's start with the continental crust. Here I have an example of a granite that was collected in central Victoria. Granites are igneous rocks and can be found in a continent. Our second example is a conglomerate, a rock that has been formed in an ancient riverbed. In this example, a rock are collected in the Flinders Ranges. This rock has been dated to be around 650 million years old. That's cool, eh? Now for the third example, we have a metaconglomerate, which is a metamorphic conglomerate rock, also continental, also found in central Australia. Our last example is a basalt, which is an oceanic crust rock, and you can see that the basalt is darker in color. If you compare a granite to a basalt, you see that granites are lighter in color and they are typical continental crust rocks, and basalts are darker in color, which are rocks found in the oceanic crust. But Mr. Da Silva, how do we know all of this? That's a very good question. Humans have been studying patterns in nature for some time, but one of the first scientists or philosophers to document patterns in rock formations was Leonardo da Vinci. He analyzed some patterns in rocks and fossils, and he proposed that the history of Earth extended far beyond human records. So here's a painting, a drawing actually, of Da Vinci. So history says that he climbed up to the top of a hill, and in getting there, he saw a number of patterns like this in the rocks, and he reproduced them in his famous drawings. Da Vinci could not understand why marine fossils or shells could be found on the top of mountains, for example. Also, we've been studying seismic waves for some time. This topic is beyond the scope of this first lesson, but I encourage you to definitely have a look at this video here on YouTube called Earthquake Science and the Disaster That Created It. Pretty cool video. Also, we have volcanic activity giving us some rocks, some exquisite rocks called xenoliths. Xenoliths are pretty much a piece of a rock trapped inside another rock type, and here's a good example. So this rock here in gray is our basalt, the one that I showed you previously, and this mineral here, in this case, is green reddish, and that mineral there, which is the green olivine, it's called olivine, is what we believe the mantle is made of. So the mantle, if we could go down there, we would see the mantle would be greenish. And here is a sample of the mantle itself. I'll show you. Here we have a very good example of a xenolith. The gray rock is what we call the basalt, a rock from the oceanic crust, but inside you can see this beautiful green mineral called olivine. And this mineral is what we believe the mantle is mostly made of. And finally, we reach the synthesis for this very first concept. It states that scientists build models to explain the world using evidence and data to support their ideas. Evidence that we'll be discussing very soon in the next lessons. However, models that explain the world where we live in might change when new evidence is collected. I would encourage you to stop the video now and copy that onto your workbook. We have plenty of activities for you now, a total of 3. So the first one, task number 1, is to access and copy the plate tectonics concept map, which is available as the assessment 1.2 activity on Style app. For activity number 2, you should be focusing and answering a very short quiz on the structure of the Earth. Very, very easy. The assessment is called 1.3 Quiz Structure of the Earth. And now to the last assessment for the day. Task number 3, create a 2-scale representation of the layers of the Earth. Great challenge. You should be working with the mechanical layer. The assessment is called 1.4 Practical. Create a 2-scale representation of the layers of the Earth. And I'll be recording a short video explaining to you how you should be approaching that task. And that's the end of today's video. I really hope that you're enjoying this content. Please do not hesitate to share this video or to send me a message if you have any questions about the content. Remember, we are working together in this new phase of flexible learning here in Victoria, and we are all in this together. I'm looking forward to see you in the next one. Take care.